Module 10 explores the cutting-edge innovations, emerging trends, and transformative pathways guiding agriculture into an ecologically resilient, low-emission, and socially equitable future. With increasing global pressure to address climate change, biodiversity loss, resource depletion, and food insecurity, there is a growing shift towards technological adaptation, ecological intensification, and regenerative agricultural systems. This module integrates scientific, technological, policy, and socio-cultural dimensions to analyze how emerging innovations such as precision agriculture, biotech applications, vertical farming, blockchain for traceability, artificial intelligence, AI, climate-smart agriculture, agroecology, and circular bioeconomy are reshaping the environmental impact of agriculture. These innovations aim to optimize input efficiency, enhance productivity, protect ecosystems, and ensure food system sustainability across diverse agroecological zones. We further examine barriers to adoption, including technology costs, farmer awareness, digital divides, socio-cultural resistance, and land tenure insecurity, while also reviewing global innovation platforms, startup ecosystems, agricultural research partnerships, and smart financing mechanisms, e.g., green bonds, carbon finance, innovation grants. By the end of this module, you should be able to 1. Analyze technological and ecological innovations aimed at reducing agriculture's environmental footprint. 2. Understand the principles and practices behind sustainable and regenerative agriculture. 3rd. Critically evaluate the socio-economic and ethical implications of agricultural technologies. 4th. Assess enabling environments and governance structures that support innovation adoption. 5. Recommend integrated system-based approaches for sustainable agricultural transitions. The need for innovation in agriculture. Population growth, climate change, land degradation, and water scarcity necessitate a paradigm shift. Traditional, industrial agriculture is unsustainable, linked to deforestation, overuse of chemicals, and emissions. Innovations must balance productivity with ecological integrity and social inclusiveness. Technological innovations in agriculture, A, precision agriculture, PA, involves use of GPS, drones, soil sensors, and remote sensing to apply inputs efficiently, reduces fertilizer, pesticide waste, minimizes runoff, and maximizes yields. B, biotechnology and genetic engineering, development of drought-tolerant, pest-resistant, and nutrient-enriched crops, e.g., golden rice, BT cotton. Ethical concerns around GMOs, biodiversity impact, seed patenting, farmer dependence on corporations. C. Vertical farming and controlled environment agriculture, CEA, uses hydroponics, aeroponics, and LED lighting in urban structures. Drastically reduces land use, pesticide needs, and water consumption. D. Artificial intelligence, AI, and big data. AI models predict climate impacts, crop diseases, and optimal planting schedules. Robotics automates harvesting, weeding, and irrigation. E. Blockchain and ICT platforms. Ecological and nature-based innovations. A. Agroecology integrates ecological science into farming practices, promotes biodiversity, soil health, natural pest regulation, crop-livestock integration. B. Regenerative agriculture goes beyond sustainability, restores ecosystems, sequesters carbon, and revives soil biomes. Practices: no-till farming, cover cropping, rotational grazing, composting. C. Agroforestry, strategic integration of trees, shrubs with crops, livestock. Enhances resilience, prevents erosion, increases biomass, and supports pollinators. D. Circular bioeconomy, valorization of agricultural waste into bioenergy, bioplastics, or compost. Zero-waste systems reduce reliance on synthetic inputs. Climate-smart agriculture, CSA. A framework that simultaneously increases productivity, enhances climate resilience, reduces greenhouse gas emissions. Components include weather-indexed insurance, stress-tolerant crop varieties, conservation agriculture, agro-advisory services, policy and institutional enablers of innovation, public-private partnerships, PPPs, for R&D, role of CGIAR, FAO, IITA, AGRA, and national research institutions, smart subsidies, microgrants, green bonds, and innovation incubators to support startups. Extension systems need digital tools and capacity building. Barriers and risks in innovation adapting. High initial cost of equipment and infrastructure. Knowledge gaps and low literacy among smallholders. Lack of land security discourages long-term investments. Market failures and lack of post-harvest value chains. Future trajectories and integrated transitions. Need for transdisciplinary approaches, blending science, policy, culture, and technology. Landscape-level planning integrates watersheds, biodiversity corridors, and farming zones. Focus on equity, intergenerational justice, and adaptive governance. This is the end of this course. Ensure to finish the module quiz and the exams to obtain a certificate of completion.